it's recording. Double checking to make sure that I am recording. So it is recording from the right channel. Okay, first thing first, where do we find the notes? Okay, because we have been I have been teaching this class out of the notes for a while now, since the beginning of this class. So you really need to know where to find the notes so that you can review what we talk about in the class. Then you also have access to all the files that I captured in the class. All the spreadsheets that I worked on, all the homework assignments, they're all on this website. So just use any browser except for Internet Explorer. And I'm not kidding, because there are people having problems with Internet Explorer authenticating into Moodle. So definitely do not use Internet Explorer. And the website is, okay, I always use HTTPS, just so that the transmission of my password and username would be protected. If you use HTTP and you log in at a cafe or some other place where you have open Wi-Fi, other people can see your transmission and they can actually grab your username and password. So always use HTTPS for secure login. So I just go to someprofs.org. The URL is someprofs.org. And you should have received your message to teach you how to log in. Your username is your 7-digit student ID without the W, and the initial password is something that the system has set for you. If you have forgotten your initial password, you can always click on this video clip here. Oh, not this one, right, this one here, how to reset a password. It will show you step by step how to do it. So I'm just going to log in, and this is the homework that's due today. So this is the first thing that I'll do, is to do my own homework to show you the solution of this particular homework assignment. Are there any questions at this point? Does everybody, yes, go ahead.
You say homework, you mean the modules? I mean the notes, you mean the modules?
Yes, the notes means the modules, the ones that I wrote. That is already online, at Moodle.
Have you been saving the little yellow sticky note thing?
The yellow sticky note thing is just a text file. Yes, I have been saving that, but I have not been posting that. So maybe I should switch to another editor just so that I can easily save it and post it. Okay. Any questions at this point? How to access Moodle? Okay. So what I'll do is I'm going to do my own homework assignment first. So save link as, but I cannot save it to just user anymore because I did not actually have this system mounted over there. So I'll have to do a little bit more work this time. And today is 09613. So I just created a folder for this class, or for today. And I'll save the spreadsheet into that folder. After this class is done, I will also upload all those files that I work on today. So this way you don't have to copy everything. You might want to spend some time to just write down the tricky parts, the stuff that I do not capture on this on-screen recording, nor the file. That's the kind of stuff that you need to write down, because if you don't write it down, there's no record of that anymore. So you need to spend time to kind of think about, what is important to you, and just write those down. And here we have OpenOffice or LibreOffice. I'll just go ahead and open the document. And it takes a little bit more time today because I could not start it natively. So I have to navigate a little bit more just to get to the files. All right, well, this is your homework assignment. And we resize the screen first. Maybe zoom in a little more before I do that. Okay, so I'm hoping that this looks somewhat familiar, because that's your homework assignment that was due about 8 minutes ago. But with every homework assignment, you want to read the instruction first. In this case, there are 3 sheets other than one. Sheet 1 each one is a test case, it has a different precondition. So your job is to trace the algorithm for each precondition. In other words, you have to produce 3 individual traces. And that's what the instruction says. Okay? So we'll switch back to the spreadsheet, and I'll explain what I mean by the 3 different sheets. So we'll go ahead and resize this. All right. This is in sheet 1, which is the algorithm itself, and this one is in sheet 2, which is a precondition, so that we can test, okay, what is this algorithm going to do when I starts with a value of 1? Are there any questions at this point? No? Okay. So we'll go ahead and trace the algorithm. We trace, starting with line 1, because line 1 is actually important in this case. When you have a pre-checking loop, the first line of the pre-checking loop is actually significant. Why is it significant? Because you need to check the condition. Yep, exactly. So whenever it is important, you have to indicate what it does on that line. For comments, when you have a conditional statement, the comment has to say, okay, what condition we are evaluating and what is the result of that condition. Is it true or is it false that I is less than 3? It is true, very good. So if you have a pre-checking loop and the condition is true, where do you go? You go into the loop. In this case, it will be line 2. Line 2 is adding 1 to I. I goes from 1 to 2. Then where do we go?
1.
You go back to line 1. Very good, because this is not a conditional statement. You go back to line 1. We reevaluate this condition. It is still true because 2 is less than 3. Then we go back to line 2. Line 2 is going to add 1 to I again. I goes from 2 to 3. Then we go back to line 1. Line 1 says, what is I is less than 3? It is no longer true. It is false now, because 3 is less than 3 is false. When the condition of a pre-checking loop is false, what do? You get out of the loop, and then you get to post, and we are done. Okay? The most common mistake with this particular test case is some people will miss row 7 entirely. Okay, and I would take some points off, because it is important to go back to line 1 first in order to reevaluate the precondition, and then when the condition fails or when it becomes false, then you get out of the loop. Okay, so if anyone misses row 7, I will take some points off. Not a whole lot, but it is important. Conceptually, this is a very important step. So that's the first test case, and then we'll work on the second test case. The second test case starts with 2, which means if you like to copy and paste, you can actually copy and paste in this case, because we are just going to copy and paste from here all the way to the end. Okay, so we'll copy this, and then we'll just paste it here. Now, after you copy and paste, it doesn't hurt to double check and make sure that the trace makes sense. We still start with line 1, which is good. I has a value of 2. 2 is less than 3 is true. And then we go to line 2. We increment the value of I to 3. And then we go back to line 1. And we reevaluate the precondition. This time I is 3 already. 3 is less than 3 is false. And therefore we get out. So it all makes sense. Okay. Are there any questions about this? No? Okay. I can actually tell who did this trick, copy and pasting from the one before. It's interesting what I can see in your spreadsheets. Okay, the last one is easier. Okay, the last one is not even worth the time to copy and paste. We start with line 1. Line 1 asks the question: I is less than 3 is false to begin with, and since this is called a pre-checking loop, it means you have a chance of exiting the loop even without executing the body once. And this will be one of those cases, because the condition is false to begin with. We go around the body of the loop, and then we go to post right away, and that's the end of this trace. Are there any questions about this homework assignment? No questions? Okay. Now there's another point that is important when I graded the one before the assignment before this one, is when do we update the value of I? In the previous assignment, some people updated the value of I on a condition line. And that would be incorrect, because only assignment statements, like the one on line 2 in this particular algorithm, can change the value of a variable. So that's why, tracing line 2 is also important too when you're dealing with algorithms like this. Any questions?
I was just wondering, when was that? I remember that you had like, it goes over the number and then it goes into infinity and then comes back or something.
Right.
So what was that?
I can make this one do the same thing if I make, I gets I minus 1. So for a few test cases, if you say I gets I minus 1, then it will keep going negative. It will keep going, the value will keep decrementing, and then it will hit the bottom, and it will wrap around, and then it will go from the top again until the condition is false.
So this isn't it?
Nope, none of the test cases in this case would get you into an infinite loop. Okay. Any other questions? No? Okay. You can also see how much time I spent to work on this one. It's 10 minutes. 10 minutes of edit time to work on this particular worksheet. Question?
Is there, I missed the other 2 sheets, I didn't read that good. Is there any trick on the next homework for Thursday?
For Thursday, well, the homework that's due on Thursday, okay, let me double check and see if there are any more questions about this one, and then we'll work on, and then we'll take a peek at the one that's due on Thursday. Are there any other questions about the pre-checking loop homework assignment? No questions? Okay. Then we'll go ahead and take a quick look at the one that's due on Thursday. That's the nested loop one. And if I click on this link directly, it will also give me a chance to open it. But this way, this time I'm not saving it into the folder that I saved for today. So this is the homework assignment for Thursday. And according to the instruction here, sheet 1 of the spreadsheet contains the algorithm. Trace the algorithm in sheet 2, so there's only one trace that you need to do. Assume that we don't know anything about the variables. So that part is important too, because you have to determine what do you specify for the variables in the pre-row, the precondition row. When you're done, close the spreadsheet program first, and then use the upload interface to upload the file, and that's it. It's basically the same instruction as all the previous assignments.
Do we have to make up a number, or can we just put question marks?
You should put question marks, because if it is unknown, that means it is not known, and you cannot just write down a particular value. Okay. Any questions about this one? Yep.
When you're going through the loops, let's say y has already been assigned a value of 0, and you can, as long as it remains 0 as you go through the different lines, you don't have to put 0 afterwards. But let's say you reach the part again where it's assigned 0 again. It's the same value as it was before. Do you still want us to put a 0 the second time it's assigned?
Yes, yes. Okay, that's a very good question. The question is, if y has a value of 0 to begin with, and you go through y gets a 0 again, do we want to indicate that y gets updated again? And the answer is yes. So every time you update a variable, even if the value is the same as what it already has, you still have to indicate it in the trace, because those are still important events when you trace the algorithm. So that's a good question. Yep.
Is there any way we could know how many lines this is at the end? Because if we get lost, do an extra one. I think I did an extra 2 lines or something.
I don't know exactly how many lines yet. I don't really have the solution of it yet. So we'll talk about it on Thursday.
All right.
So you have to rely on what you learned about the material to kind of help you do the homework assignment. If it's not too far off, you won't get that many points dinged. So I would just do it, as you understand it, and then see what happens. Any other questions? No other questions? Okay. So since we are on the topic of homework assignments, let's move on to the next one, the one that I just made up this morning: pre and post conditions with assignment statements. So this one is a little bit different in terms of format. There's no trace here, okay? This is not a trace homework assignment. So that's the first part that you have to remember. If you use a spreadsheet to work on this one, you're probably not understanding the question correctly, okay? So for this homework assignment, I want you to use the pre and post conditions, not tracing, to show me what the following algorithm does. The algorithm consists of exactly 3 lines. The first line says, x gets the value of z, x gets x plus 2, y gets y minus 2. Those are the 3 lines that you have to derive pre and post conditions for. Use the conventions and notations that I use in the class. Be sure to indicate the following. So I'm going to go through some examples today, and I will follow my own instructions to make sure that I conform to all of these standards. For each line, you have to indicate what is the precondition, what is pre-1, what is pre-2, what is pre-3. For each line, you have to specify which rule applies. We talked about the forget rule last Thursday, and today we'll talk about another rule called the substitution rule. So you have to pick between those 2 rules and tell me why you pick the one that you think is appropriate. The third step is a little bit longer because you have to apply that rule. When you apply the rule, you have to do it step by step. Okay? Once again, what is the precondition? So that's the same as the first part here. The rule in its original form relating the post condition to the precondition. We'll talk about that. You have to plug in the actual precondition, then you apply the transformation and derive the answer. And there's no need for you to simplify the answer because I am not assuming that everybody has gone through algebra. So if you don't know how to simplify stuff, that's fine, it's not a problem. The only thing I give you as a precondition is pre-1. The precondition of line 1 is that we know, for some reason, we know that z has the same value as y. We know that x is less than w. And we also know that z is different from v. Those are the things that we know before line 1. So your job is to tell me, what do we know after line 3 executes? There's no way you can trace this one. Why do you think there's no way to trace this one? Because I did not give you specific values. And that was intentional. Because last time or last semester, the same kind of homework assignment, I gave people specific value. Some people ended up tracing it because they thought, this is a trace exercise. This way, there's no way you can trace it, and you have to use the pre and post conditions to tell me what the algorithm is actually going to do. You can use Microsoft Word in this case. This is one of the very few homework assignments where you can use a Microsoft product. You can also use OpenOffice or LibreOffice Writer, which already is installed if you have Calc already. You can use Microsoft WordPad in Windows. You can use Microsoft Notepad in Windows, or just about any other text editor that you can find. There are people in the past who try to use Microsoft Works, or WordPerfect, or WordStar. I cannot read those particular files. But I think there should be enough alternatives already, given the first 4 options. Does anyone have any problems with this one? Not like my only editor is WordPerfect. No? Okay. All right, so what I'll do is I'm going to keep this one on screen because as we talk about the pre and post conditions of assignment statements, this will become useful. So we'll go ahead and open up another tab, and I'll show you the notes that we're on. I have gone back and actually used the highlight tool in Moodle so you know which topic we are in for a particular day. It was not set up correctly earlier, but now it is correct. So when you see the orange slash beige color tab here, that's the current topic that we're in. It really helps you locate the notes quicker. But you can also see these files. When you see these files, you know that we talked about pre and post conditions on the 8th of September. So there are several clues you can actually get to remind yourself what we talked about. And of course you can also rely on YouTube. Do you guys still remember how to look up my notes on YouTube? Yes. You go to YouTube, you look up cisp300, you type in the date code of the class that you want to look up. In this case, let's say we want to look up what we talked about on the 8th of September. then it's 2011, 09, 08. And we have this one here, okay? So that's how you can find the lecture recording of a particular date. I used to post the links, through Moodle, and I stopped doing it because I just rely on the date and also the class code, and it's easy to find. I mean, if you look up a calendar, you know automatically, okay, what is the date range that I need to find, and then you can use YouTube and use the search facility of YouTube to help you find it. Okay. Any questions at this point? The questions, let's go ahead and go ahead.
I think in the pre and post conditions there's a link in there. I forget exactly where. No.
Oh.
I guess it was something else.
You mean
But
this one here?
there was like a click here to access the files, and it referred to documents from the 2009 class that
Oh,
didn't
okay.
have permissions.
I might have deleted those already.
Okay.
Yep. Did you try it like recently or?
No, I just remember going and
Okay.
looking at it and trying to.
Yeah, I removed
access it.
links to really old files. Okay, so let's go back to pre and post conditions, and we have already talked about constant assignments, but we did not talk about the rule itself. We also talked about self-referencing assignments. Something like this line here, line 3, is what I call a self-referencing assignment statement. So what we'll do today is to talk about these assignment statements, and then we'll figure out how to do the homework assignment along the way. And I was using notes before, but it wasn't very effective as a tool. So I think I'll try GVim today, and I have to bump up the font size first. So let's go ahead and select a larger font. Is that big enough? Okay. So we'll go ahead and just use one example. This is something that we did last time. Not exactly the same, but close enough. So let's say line 134 is a line that is really simple. Z gets Z plus 1. Okay. When you see less than and a minus symbol, when they're grouped together, it is a representation of the assignment symbol, which is a left arrow. So this does not mean Z is less than negative Z plus 1. It simply means Z gets Z plus 1. So let's just say that we know something about the precondition of line 34. In other words, for some reason, someone told me that this has to be true before line 134 executes. So we'll just say that just some random fact. Let's make it. Let's make this really simple first, okay? Because I just want to kind of do a warm-up first, and then we'll start to get into the more tricky ones. So we'll just start with a very simple case where, okay, I was told that whenever I'm about to execute line 134, Z is going to have a value of 16, okay? So the question is, what exactly is the value of Z after line 134? 16. Z equals 16, okay? That's pretty easy, because in this case, we can actually trace it. It's not a big deal. Okay, so we'll just talk about this as case 1. Okay, now we move on to case 2. Now in case 2, let's just say that it becomes a little bit more abstract. Let's say that before we execute line 134, we always know for sure that Z equals W. Okay. So the question now is, can we say something after line 34 executes?
W plus 1.
Z equals W plus 1. Very good. So that is Z equals W plus 1. So let's go for one that is even more complicated. Okay. So this time, let's just say that someone told me that Z. Let's make it more complicated. Let's make it look complicated. It's not really that complicated. We'll just say that Z divided by 2, the whole thing, plus X is less than 2 times W. I'm just making it, arbitrarily, complicated, divided by Y. Okay, that looks good. Okay. And let me make sure that we save this file to the right place. Okay. All right. So what do we say about the post condition in this case? Now the first case is definitely easy because we know that Z has a very specific value before it executes, so it's no big deal. The second one, case 2, is easy too because at least it equals to W, and we know that the statement is going to increment Z by 1, and therefore it is easy to state, okay, Z still relates to W, but the relationship is tweaked a little bit, okay? But case 3 seems to be awfully difficult because the equation here, or the inequality in this case, is complicated, okay? So the question is, how do we solve this? So instead of showing you guys, how to solve this, I'll just give you the solution first, and then you guys tell me whether the solution makes sense or not. The solution is copy and paste, and just say that. That's my solution. I did not simplify anything, but I got to the truth. I got to the answer. Does that make sense?
Why is it minus 5?
It's not? No, it's Z minus 1. If you think about it, okay, what do you think line 134 does to Z? It adds 1 to Z, right? So after we add 1 to Z, post 134 is basically saying after line 134 executes, how does Z relate to X, W, and Y? That's what it's asking. Since we know line 134 just added 1 to Z, don't you think if we subtract 1 from Z at that time, after line 134 executes, we'll get back to the original value of Z? It's an undo, right? So once we get back to the original value of Z from before line 134, don't you think the rest of the inequality will still be true? It still makes sense. Okay, now you guys are not, you don't look convinced to me. Let me ask you this question. If I just take Z and replace Z with Z minus 1, is that the same thing? Oops, sorry.
Yeah.
It's the same thing. What about in this case here? Can I just say that we will keep the original relationship, but we replace Z with Z minus 1? Is that the same thing?
Yeah.
It's the same thing. It makes sense. Because Z minus 1 in this case is what we call an undo function. Okay, all it does is to say, oh, let's pretend line 134 never happened. Now, if that line never happened, how do we relate the value of Z to everybody else? That's what it's doing. Is that making sense or not? Yep.
Then why didn't you, for the case 2, why didn't you do, since you did Z equals W plus 1, can you do the same thing like on case 3? Instead of use a minus 1, like use some other form? Like you could use 2 forms, 2 posts?
They're the same. These two are already the same. Right?
Yeah, so is there a different way to make the case 3 post the same?
Well, you can solve this and make it complicated on the other side, but this is the easiest way to do it. Okay. Any questions at this point? Yep.
So situations like that, just use the undo functions?
Yeah, basically you just have to undo what the statement does, and then once you undo what the statement does, then whatever was true before will still be true. The key is, can you undo it? Because certain operations are not undoable. It's a one-way street. X gets x plus 1 is undoable because you can always just subtract 1 from the variable and get back to its value before the subtraction. You had another question?
I was just going to say, so if you were to say z minus 1 equals w on case 2,
Yep.
that'd be fine.
That will be a perfect answer as well because these two are actually equivalent. Z equals to w plus 1 and z minus 1 equals w are equivalent. They say exactly the same thing. Yep. Are we doing okay or not? Yes? Yep, go ahead.
If you say if you were to give like a value for z, like say if you were to give like 1, can you insert that just to test it, like if you were correct or not? So like you can see that your post case like shows that it was it relates to the pre case.
Oh, you mean just plug in specific value for these things?
Yeah, so like z plus 1, and then like on that part right there you add say z equals 1, so that'll be 1 plus 1, it'll be 2. So on your pre case.
You mean for case 3, you want to have
for case 3, like,
specific values of z, x, and w and y, and make
yeah,
it.
would it work though? I'm just saying would it work? Like if you were to like, make sure it's right. If you
Okay,
were-
sure, we can do that. Now, but to do that as an example can also introduce confusion in this class because we are not really tracing it. But I understand what you're saying.
Well, just the z value, not like all the other values. I'm just saying like just to prove that that's right.
Okay. So basically, what you're saying is, we can just say that z has exactly a value of 10, right? That's what you're saying. So basically, after this, we can say z minus 1 equals 10. Is that right? Now let's think about it. Okay, let us forget this big mess on this side. Okay, just forget that side, and we'll just focus on the other part. If we know that z equals 10 before the assignment statement, don't we know that z equals 11 after the assignment statement?
Yeah.
Yep, okay. So I'll just say that z equals 11. If you know that, okay, so I'm going to do my copy and paste here. If you know that z equals 11, isn't z equals 11 the same thing as z equals minus 1 equals 10? Is that the same thing? It is the same thing. So that means wherever z goes in the original inequality, I can now plug in z minus 1 into the same thing. Does that make sense to you?
Yeah.
Because z minus 1 equals 10. So if 10 divided by 2 plus x is less than 2 times w divided by y, then it is still true because I never touched x. X was not modified by that line. W was not modified, and y was not modified either. Is that helping you to understand why the subtract 1 is the correct thing to do to z? Yep. Yep.
Yeah, that was.
It's okay?
Yeah.
Okay, you just need to spend some time to to kind of let it soak a little bit. Yep.
What if we executed an algorithm that gives you a denominator of 0? Does that ever happen? Or is that just algebra?
Well, if y is 0 to begin with, then it's just that's a bad situation.
Yeah, so it's
Yeah, you can assume that won't happen. Yep.
Does that only work when there's like a inequality or equality?
It
Like if
doesn't
there's
matter.
not-
Just replace z with z minus 1 everywhere. You find z in the original expression. You replace it with z minus 1, and all will work out just fine. Yep.
Can you also say that post 134 is z divided by 2 plus x is less than 2w divided by y plus 1?
No, it's not. You cannot just do a plus 1 on the other side because, well, if you want to do a plus 1, you have to say plus 2 because this is z divided by 2.
That's right, okay. Plus
Well,
2.
actually, I take it back. You have to say plus 1/2 because of that.
Yes.
It's
okay.
just easier to replace z with z minus 1 than to do something on the other side.
Okay.
Yep. Okay, so this would be a good time to introduce the concept of what a function is and what an inverse function is. A function is simple. Okay, so look at f of x. I'm defining a function. F of x is let's say x plus 2. Okay, now what does that mean? What is f? What is the function f in this case? It's a shorthand. That's all it is. It's just a shorthand to say that, whatever is inside the parentheses after the f, you just have to add 2 to it to get to the value that we want. Okay? Well, the reason why we have function like this in mathematics is because sometimes they have really, really big formula on one side, and you don't have to rewrite that thing over and over and over again. So it is much easier to just to say, oh, let's define f of x to be blah, 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 blah here. Okay, these are all the things that we need to work on using the value of x. But from now on, whenever I want to refer to blah, 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 blah here, I just have to say, oh, apply function f to blah, 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 okay, to a single value. That's basically a shorthand. So let's go through a few examples of what functions can do. What do you think is f of 0? Okay, you just take whatever is inside the parentheses and replace it, put it into the equation. So it becomes 0 plus 2, and this thing becomes 2. Is that okay so far? What if I have f of z? And it becomes just z plus 2. Whatever z is, we add 2 to it, and that becomes the outcome of the function. What about f of, let's make this complicated, and you guys can tell me how to deal with it. F of x plus 1.
X plus 3.
Okay, well, so the original form is going to be x plus 1 plus 2. Because we just take whatever is in the parentheses of the function and add 2 to it. But since you already know that with addition, you can basically reorder the how you group the parentheses, and you basically end up with x plus 3 in this case. What is that rule called? When you can say that, oh, we can just take we can remove this pair of parentheses and group it like this instead. What is the rule of? What is the name of that rule?
Commutative?
Nope, it's called the associative law.
Ah.
Yep. Commutative means you can reverse the order.
Oh.
X plus y equals y plus x. That's the commutative rule. Okay. All right. So now that we have a basic understanding of what a function is, let's think about what is an inverse function. Think of an inverse function as undo. Okay? Pick your favorite editor. Control Z is an inverse function because it takes whatever the function did to something and just reverse it back to the original form. Okay? So in this case, if f of x is once again x plus 2, what do you think is the inverse function? Normally, people or mathematicians would use f to the power of -1 to represent, an inverse function. But since I'm using just a regular text editor, it will be very hard for me to do that. So I just use f prime to indicate the inverse function. So what do you think will reverse x plus 2 and get us back to x?
Minus 2. X minus 2.
X minus 2. Okay, very good. X minus 2 is the inverse function of that. Now, how do I know this is true? Well, the way you know it is true is you can apply f of x, you can apply f to f prime, apply to x here. That looks awfully complicated to me. But how do we deal with it? One level at a time. Okay, one level at a time. What does function f do to whatever is inside the parentheses? It just adds 2. So the first step is just to take care of function f. We just take whatever is inside the parentheses, the outer parentheses, and just add 2 to it. Fine, okay, we know how to do that. What is f prime of x? According to the definition here is x minus 2. So now we have x minus 2 plus 2. And by using the associative law, what do we get? We get x back. So this is a proof that in this case, f prime is the inverse of f, and vice versa too. Basically, when you have inverse functions, they are the inverse of each other. Okay. Now, just as an exercise for yourself, I don't need to collect this one, but you might want to try this. Okay, apply f prime to f, apply to x, and after some derivations, you should also be getting back to x. Okay, it's nothing more than just expanding the functions and doing all the simple algebra thing, and then get back to x. Yep.
So it's going to be
It'll be x plus 2 in parentheses, the whole thing minus 2. Yep, so you still get back to the original. Are we doing okay so far with the concept of what a function is and what an inverse function is? Going okay? Okay. So let's go back and take a look at this case here. Let's take a look at this one here, line 134. Line 134 is kind of special because the variable on the left-hand side, which is z, is also appearing on the right-hand side, z plus 1. That's the first thing you need to know is, do we have a self-referencing assignment statement? Self-referencing means the right-hand side refers to the left-hand side. The variable on the left-hand side is in the formula of the right-hand side. This meets that requirement, which is the first requirement. The second requirement is, if I make function f as f of z to be z plus 1, is there an inverse function for that?
Yes.
The inverse function is z minus 1. Okay, so now that you have an inverse function, we have met the second requirement, which means, in this case, if you are given the precondition, getting to the post condition is going to be a snap. Okay? Let's see what I mean by this is going to be a snap. I want to keep this one up, so we'll split the screen, and so I can scroll the bottom half without affecting the top half. Okay. So for line 134, let's evaluate those two requirements. The right-hand side refers to the left-hand side. That's the first requirement. If the right-hand side does not refer to the left-hand side, forget it. You're not going to apply this rule at all. So that's the first requirement. The right-hand side, we'll call this f of z is z plus 1. In other words, we just arbitrarily define a function to be the right-hand side of the assignment statement. We just assign a name to the function on the right-hand side. Is that okay? If you don't like f of something, you can call the function g, you can call it h, you can call it whatever letter you want to pick. Has an inverse. Because if f of z equals to z plus 1, it has an inverse function of what?
Z minus 1.
Z minus 1. Very good. Now that we have these two requirements met, we can now use what I call a substitution rule. You can apply the substitution rule. Yes, I know how to spell substitution. Substitution. Go. But in the class, I just call it a sub rule, okay? Now, what is a substitution rule saying? Well, this is a template. The template is saying the post condition of this line, which in this case is line 134, is a substitution operation applied to the precondition of line 134. Now, when we say substitution, that means you have to find something and replace it with something else. Is that what you understand the substitution or replace means? Okay, it's just like in a word processor, when you say, I want to replace text, then you have to specify what are we looking for and what are we replacing those things with. So now you have to specify what we are looking for. We are looking for the variable name that appears on the left-hand side. So find me all the occurrences of variable z in the precondition of line 134, and what are we going to replace it with? We replace each occurrence with f prime applied to z. This is the template. This is very important as a template because you have to start with this one and then go forward step by step in your homework assignment. Does that make sense though? The notation is kind of distracting in a way because it is kind of complicated, but if you just take a step back, not really worrying about the notation, does it make sense? We look at the precondition of line 134, we take all the occurrence of z and replace every single one of them with z minus 1. it makes sense because z minus 1 is going to undo what the assignment did on line 134. And therefore, whatever z appeared in line 134, if we replace it with z minus 1 using the value of z after line 134, it will still be true. Is that okay? So once you have established this part here, the second thing you have to do is to say, okay, but what exactly is the precondition of line 134? And in this case, we can pick case 3. So let me move this one down a little bit here. I just want to pick the more complicated one. So we'll pick this one. Oops. Okay. We'll pick this one here. I just copy it and paste. Okay. And the rest is still the same. We're still looking for z and replacing z with, in this case, z minus 1. Can everybody see what I did from this line to the second line? What changed between those two? Nope? Okay. What I did was I looked up exactly what was pre-134 in this case, and I just expanded that to whatever it was. Since I'm using case 3 as an example, I have to copy and paste the whole thing. Is that okay? And then the second thing that I did is instead of referring to the new string or the new text as f prime applied to z, I just state exactly what is the inverse function of f applied to z. So those are the two changes that I made in this case. Do those changes make sense? They're just substitution. I'm just replacing these terms with exactly what each term means in this specific case. All right. So if that makes sense, then the next line is just applying the operation. So we'll just go ahead and carefully, locate all the occurrences of z. Okay, there's a z here. I replace it with z minus 1. The rest remains exactly the same. There's another z here. I replace it with z minus 1. The rest are exactly the same. And I have the answer. Any questions about this part? So, no?
Yeah.
Okay, the first question is it mechanical?
I hear what you're saying. It's just not sticking.
Not sticking? We'll have more examples. It will help to make this stick, as we go through more examples.
This is due next Tuesday, right?
This is due next Tuesday. Okay. Yep, go ahead.
So that first one under post 134, right where it says sub pre 134, comma z, f prime z, right?
Right.
Right there, we're just identifying what we're going to replace.
Yes.
That second line is saying what we're going to replace z with.
Correct. Because f prime of z,
Right.
as identified here,
Right.
is z
Inverse.
minus 1.
Okay.
And the precondition is already given to us, and therefore we just plug in the entire precondition as given to us.
And then the third line is what the result of the inverse function would be.
Correct.
Okay.
This is the actual application of the substitution operation, so that we replace this z with z minus 1, we replace this z with z minus 1. Yep.
And why are we using the inverse? Why?
Because we are undoing what the assignment did to the variable, so that we can
Where
get
do
back
we
to
find that information that we're supposed to undo it?
You undo it using the inverse function. The inverse function is you take the right-hand side as a function, and then you find out what to do to undo it. Yep, go ahead.
Why are you using the inverse function? Why are you trying to go back to the precondition?
So that we can still say something about the variables. Because otherwise I cannot say anything. Once you do an assignment statement on something, how it relates to all the other variables can potentially be lost. I don't want to lose that information if I can't keep it. And here I'm
because, I mean, at the top it says, Z plus one is Z, right?
You mean the assignment statement here?
Yeah,
This
that's
is
true.
this is saying.
That's just a statement.
Well,
Next
this is
one.
another. Okay, wait, hold on a second here. Okay, this is important because line 134 is not saying that Z plus 1 is Z. It is saying
Whatever's in Z register plus one, then we're gonna put that number back into Z.
exactly. So the
Okay.
effect is we are incrementing the value of Z by 1,
Whatever it is.
or whatever it was. Yes.
Yes, so it's gonna be one more.
Right.
Why are we going Z minus one? Why do we want to go back?
Because this is host 134. In other words, this Z refers to the value of Z after the increment. This is the post increment value of Z after line 134 executes. So in order to maintain the relationship of Z and all the other variables, we have to say, okay, this is the value of Z after the increment. So that means this part here is the value of Z before the increment. Is that making any sense?
Yes.
And once we know the value of Z before the increment, isn't that the same thing as the value of Z with, pre-134?
Yes.
And isn't this the rest of it just a copy and paste from pre-134?
Yes.
That's why. Is that okay? I mean, I know it's a little bit tricky because most people think, why are we using the inverse instead of the function itself? And that's why, because we are undoing what the assignment did to the variable.
We want to know what Z was prior to 134.
Exactly. So that we can basically just say that whatever was true is still true, except it does not apply to Z anymore. Now it applies to Z minus 1.
So instead of going forward, we're going backwards, up the.
We are trying to say that whatever was true in the precondition is still true, but it does not apply to Z anymore because we have just added 1 to Z. So we have to say, oh, take 1 away from Z, then everything will still be true. That's basically what it's saying, but in a mathematical way. Okay. Now this stuff can come in handy. I know this. Remember, what I said, before this one. That it seems to be a lot of math in this class, or particularly this portion, and this is why I said that, because it's not just the math, it is the abstract understanding of why we are doing this that is important. Okay. All right, so let's go back and let me stop the split here. Go back to one single document. Okay, let's go through another example just to make sure that we understand how to do this. So we'll go ahead and invent another line 65. And once again, we'll use something that is relatively simple. Okay, we'll say that this time x gets x times 2. Okay. And in order to do this, I have to give you the precondition of line 65. So with this, we'll just say that w equals to 2 times y, and x is less. Oh, okay. Let's make this slightly more complicated. So we'll say x times y, the whole thing is greater than z. Okay, that's it. Okay, so don't ask me why pre-65 is like this. It has to be given to you or derived from line 64 and so on and so forth, depending on the structure of the program. So in this case, you have to answer the 2 questions again. Remember what those 2 questions are? First of all, well, before the inverse, we have to answer this question. Does the right-hand side refer to the left-hand side on line 65? The answer is yes, right? Because the right-hand side is x times 2. The right-hand side is the left-hand side is x. The right-hand side is x times 2. So this question, the answer to this question is yes. Then the second question is, if f of x is the right-hand side of the line, which means it is x times 2, can we find an inverse function to f? If the effect of the line is to double the value of x, can we reverse it?
Yes.
And how do we reverse that? Divided by 2. Very good. So f prime of x is x divided by 2. Is that okay? Multiply by 2 is undone by divide by 2. We can apply the substitution rule because we have those two requirements and they're both met in this case. Yep.
And right on the pre is where you put x over 2 times y is greater than z.
Well, let's go through the exercise and the answer is yes, but we want to kind of do it step by step, okay? Because in your homework assignment, you have to do it step by step as well. So the first thing we want to do is to just do the quick template and just say that the post condition of line 65 is a substitution operation applied to the precondition of line 65. But whenever you specify a substitution operation, you have to specify what are we looking for and what are we replacing it with. In this case, what are we looking for?
X.
We're looking for x because x is the variable on the left-hand side of the line. And what are we replacing it with? Well, there has to be a reason why we have to find the inverse function. The inverse function of x. That's the whole reason why we have to get the inverse function, because we are replacing x with the inverse function applied to x. And you will see that this template does not change. It is always the same. The template is always the same. Okay, so now we are just going to look up what exactly is pre-65. Okay, pre-65 is this bunch of stuff here. So we'll go ahead and copy and paste it. All right. The next question is we are replacing x with what? F prime applied to x. But what exactly is f prime applied to x? X divided by 2. Very good. So now we can just go ahead and apply the substitution. Is there anything to do for this part of the precondition? No, because it does not. There's no reference to x here. So we just keep it exactly the same as before because there's no x. But in this case, in the second part, we do have one reference to x, and that is the only place where we have to replace it with x times x divided by 2. And then the rest of it, we just keep it the same way as before. And we're done. Are we doing okay with this part here? So when you do your homework assignment, I expect that you will do the same thing, but replace with the appropriate items specific to your homework assignment. Okay? Is that okay? All right. Okay, well, now we know how to deal with cases like this, but let's go back and talk about cases like, what about line 78 here that has a equation or an assignment statement that looks like this: y gets the value of x plus 2. Well, let's think about this one. Remember the first question? Does the right-hand side refer to the left-hand side on line 78? No, does not. Well, in this class, if the answer is no, then you have to immediately, you know that you have to apply the forget rule. Okay? So in this case, if the answer to the first question is false or no, then we say we have to apply the forget rule. Now what is the forget rule saying? The template of the forget rule is about the same thing, but it looks a little bit different. The forget rule is saying the post condition of line 78 is we have to do something to the precondition of line 78. Okay, because some parts of the precondition of line 78 may not be true anymore, or I cannot guarantee the truth of those particular parts anymore. But at the same time, I know something has to be true in this case, because after line 78, y must be the same as x plus 2. Is that making any sense? So I know the syntax for the representation can be a little bit distracting, But once again, we have to take a step back and understand, does it make sense? The post condition of line 78 depends on maybe some parts of the pre-78 I can still borrow. But some parts may have to be removed because I just changed the value of the variable. But after I change the value of the variable, don't you think that I can at least guarantee that y equals x plus 2 in this case? It has to be true. Okay, so that's the template. And then the next thing we do in this case is actually easier because the forget operation does not require substitution, and there's no inverse function in this case, because the reason why we have to apply the forget function is exactly because there's no inverse function. If there's no inverse function, you have to say, well, we might have to toss something away from the precondition. So in this case, I have to say what is the precondition, and I did not say it. So I have to, in this case, I have to supply that first. So we'll just go ahead and say that x is less than 30 and y is y equals z. Okay. So in this case, you basically just take whatever pre-78 is and plug it here. X is less than 30 and y equals z. And then the other part is just copied like that. So now we just go ahead and apply the forget operation. Which part are we forgetting? Oops, excuse me, I missed one more part here. When you specify the forget operation, you have to say components that contains this variable we have to forget. So which variable are we talking about here? Y. Very good. So I forgot about that. Sorry about that. Okay. Okay, now when you look at these conditions, x is less than 30, y equals z, which one contains references to y? The second one. The first one we can keep. So we keep the first one, but we have to forget the second one, and therefore the name forget operation, because even though we knew that y equals z before the assignment statement, we can no longer guarantee that condition. Okay? So that we have to remove that, and it is now forgotten. But don't forget the thing that is after this, which is y does equal to x plus 1 at this point, and we're all done. So yeah, go ahead.
If x is less than 30 and you add 2, oh no, that don't matter, does it?
It is possible that after the assignment statement, the equality still holds. It is possible. It's just that it's not guaranteed.
You don't have to say x is less than 28 or less than 32. That doesn't
No. We know nothing about what happened to x because line 78 does not do anything to x at all.
Okay, I got it.
And we just knew that x was less than 30, but because we didn't do anything to x, we can keep it the same thing and just say that, well, x is still less than 30, but we know nothing else about x at this point, except we also know that x plus 2 is the same as y, because that's exactly what the assignment statement does. Okay. Now, a most common mistake in this case is not to use an equal symbol here and instead use an assignment operation here. That would be incorrect. Okay, do not do this. Why don't we do this? I mean, aren't these two things about the same thing? The assignment operation and the equality. Because to me, the assignment operation guarantees the equality. So why don't we just use the assignment operator in place of the equality symbol? Why not? Because one is stating the fact that x is the same as x plus 2. The other one is specifying the operation of we are updating y with x plus 2. In this case, we are stating the truth. Okay, we are stating how one variable relates to another one. We are not trying to state what are we doing to the variables. So that's why we don't use the left arrow in these cases at all. Are we doing okay so far? Let's go through one example that has both of these things so that you can relate that to your homework assignment. So I'm just going to put a little separator here to make it clear. And we'll start with line, doesn't matter, doesn't have to start with line 1 at all. We can start with line 55. So line 55 says, y gets, are you guys up for something a little more complicated? Something more than just adding and dividing? No?
Yes. No.
Okay.
Yes.
How about something like this?
Yeah, that's good.
Okay. And then we go to line 56, and we'll say z gets the value of y plus minus 2. Okay, doesn't matter what it is. Okay, so the first thing I have to do is if I were to turn this into a homework assignment, I have to give you what is pre-55. Otherwise, there's nothing you can do. So I have to, in this case, give you what is pre-55, and I'll just say that y is less than x, and z is greater than 2 times w plus y. Okay, so that's what we know before line 55. Immediately before line 55 executes, this is what we know. Okay, so we have to deal with this in a sequence. What do you think we can use with line 55? Remember those 2 questions? Let's ask those 2 questions. Does the right-hand side of line 55 refer to the left-hand side?
Yes.
The answer is yes. Very good. But then we have to ask the second question, because there are certain things that are not reversible. So we have to ask the second question. The right-hand side of line 55, f of y equals to just what? Guess what? Copy and paste the whole thing. Does it have a reverse function or not?
Yes.
It does have a reverse function, and the reverse. How do you reverse something like this?
Divided by minus 1. Minus 2.
Y minus 1 first, and then the whole thing divided by 2. Now, it doesn't seem to be very obvious. Okay, this one does not look as obvious. So the question is that the right thing to do? Well, go ahead and plug in some numbers. Or better yet, apply f to f prime, apply to y. Because we should be able to get all the way back to y in this case. That's the whole purpose of an inverse function, is to get back to the original variable. So the question is, can we do that? Well, let's try. Let's give it a try. Okay, whatever f does is basically just 2 times whatever is inside that. In this case, it is f prime of y, and then just add 1 to the product. Is that step okay? I'm just taking whatever is inside the parentheses, the outer parentheses, and say, okay, we multiply that by 2, and then we add 1 to the product. So this part is okay. And now we expand what is f prime of y. F prime of y is this mess here. So we'll put it in parentheses, y minus 1, the whole thing divided by 2, and then we have add 1 on the outside. Okay, so now we have to do the multiplication. Now this looks like a big mess, but you can see that this 2 times is canceled by divide by 2. So now we have y minus 1 left, and then the whole thing plus 1. Y minus 1 plus 1 equals to y. In other words, I have just mathematically proved, that f prime of y, like this, is in fact the inverse function of the original function f. Is that okay? Well, as I said, this is a little more complicated than just adding 1, subtracting 1, or dividing by something. All right, so now that we have both requirements met, which rule do we use? Substitution rule, okay? Use the substitution rule. And the substitution rule states that the post condition of line 55 is a substitution operation applied to the precondition of line 55. What are we looking for?
Y.
And what are we replacing it with?
F prime.
F prime applied to y. And then the next step is just copy and paste. So we just take whatever we have here as the precondition, paste it here, And we also expand f prime of y. F prime of y is y minus 1, the whole thing divided by 2, like that. And then we just go ahead and actually apply the operation. The first condition, or the first comparison, y is less than x, does refer to y, so we have to do that substitution. So in this case, we say y minus 1 divided by 2, the whole thing is less than x. The second one also contains y, so we have to replace that reference to y as well by y minus 1, the whole thing divided by 2. And then we have the answer. That's it. Okay. Now I know that some of you is just itching to simplify this thing. Don't do it. Okay. There's no need to simplify it. Just leave it the way it is. It's fine. Now here we have a problem because now we need to move on to line 56. But I didn't give you the precondition of line 56. What are we going to do?
It's the post condition of 55.
It's the post condition of line 55. Why?
Because that's the next sequential operation.
Exactly, because they are sequential to each other. Yes?
Do we have to write that?
Yes, you do. So you have to say pre-56 is the same as post-55 because these statements are sequential. Okay? Because you have to establish that link. Otherwise, there's no way you can get to the next statement and say, but what is the precondition of this guy? Well, you can just borrow it from the post condition of the line before because they are sequential. Okay, so now that we know what is pre-56, and if you want to, you can just restate that. Okay, it's always helpful to restate it so that you have a fresh copy of it. Okay, now we have to ask the same questions again. Does the right-hand side of line 56 refer to the left-hand side?
No.
The answer is no, and if the answer is no, what do we do? Use the forget rule. Okay. Use forget rule. Don't say forget it, okay? Because we don't want to forget the homework. We want to forget certain parts about the conditions, not the homework itself. Okay? So when we use the forget rule, what does the template look like? The post condition is based on the precondition, but something about the precondition may be forgotten. And what are we forgetting in this case? Let's go back to the statements because it has scrolled off the screen. We have to forget anything that mentions z. Okay. So we'll go ahead. I'll just split the screen like before. Okay, so we are looking for things that contain references to z, and we have to forget all of those. Are we done?
No.
What else? What else can we say?
Z equals y minus 1.
Exactly. Okay, very good. Don't forget the second part. All right. Now that we have this part here, we can just go to pre-56, which is a kind of long line here. But you just copy and paste it, and that's why it's nice to use an editor for this kind of thing, because you can just copy and paste it. That. All right. What is the result of the forget operation? Does the first condition contain any references to z? No. So we get to keep that. So we'll say y minus 1 divided by 2 is less than x. It's still true at this point. What about the second one?
Yeah, yes.
It does contain a reference to z, and because we just updated z to y minus 2, that may not be true anymore, and we have to remove that. We have to forget it. Are we done?
No.
No, we have one little thing. Z equals y minus 2. And now we are done. Okay, so this little snippet of pre and post derivation actually answers all the questions that you should have for your homework assignment. Now, I did not do a forget rule and then a substitution rule. I did a substitution rule first and then the forget rule based on the nature of the assignment statements. Yes?
So our homework assignment is going to be the forget rule, substitution rule?
Some parts of it. You have 3 lines. I mean,
Give us 3 lines.
you have 3 lines in your homework assignment. It's only 3. See, only 3 lines.
Why did you miss 2 lines? 2 lines would be enough.
No, you guys can handle this. I mean, we don't have anything like 2 times x divided by minus 1 or x minus 1 the whole thing times 2 or something like that. So this is something that you can handle, and you have a whole week to work on it too.
The last screen is the screen that we're looking at.
Say again?
Can we go back to the screen that is
Sure. Hold on a second, we are not done yet. We still have a minute and 10 seconds. Now remember the text. Okay, remember the text file, and also the spreadsheet that I worked on today will also be saved and uploaded to Moodle. So if you just forgot to type something or write down something that I already have captured here, don't worry about that part. Okay, so focus on the concepts. And we have. Well, I'll let you go. We have 40 seconds ahead of time. So.
I'm tired this morning, that's why.
Okay. Well, let's try not to be. Okay. Just try your best.
I'm gonna watch the lecture.
Okay.
One thing about like when you're writing, we can just kind of try to keep it.
I would say so.
So this part
still don't have the spots open. I forgot to take roll today.
The way they made it so that
So you guys have to remind me to take roll.
So we shouldn't sign it, right? We shouldn't sign it then, right?
Yeah, well, it's okay. I'll just take it on Thursday.
Maybe
Just a quick question, again, on your notes today. I do write down notes, by the way. Can you go over, just before you make that connection, whether you use a forget rule or not, when you say there's a left, right-hand side